Okay guys, today we're going to talk about a new topic which I called XY axis. I'll try to find out first what's the point. XY axis is about two axes that are perpendicular to each other. So imagine two segments that are perfectly perpendicular to each other. A very famous application is here. You can see New York and Central Park, and all the streets are perpendicular to each other, and each street has a number and each avenue has a number. Not Fifth Avenue is very famous, and so on and so on. Broadway is very special because it's a diagonal. It's a bit what you have here in Barcelona. Not many cities in Europe are designed this way. Barcelona is famous for it. Okay? It's got XY axis, which is streets and let's say avenues are perpendicular to each other. You can see here at the top you get one that is diagonal to everything else, to the entire system. You call it la diagonale. Anyway, XY axis is very important. It seems like a simple idea of placing two segments perpendicular to each other, but it's so cool because you can locate any points on the system. Okay, so imagine you want to find out where Russia is, or let's take something a little bit smaller, like New Zealand. Okay, and you should have done that with Mr. Mark. You have longitude being the horizontal axis and latitude being the vertical axis. So thanks to this system of XY axis, X, you'll see later on, it's going to be the horizontal, and Y being the vertical, you can locate any dots anywhere on Earth. Okay, so imagine the power of GPS thanks to that. Another way of using it is seeing the evolution of something like the business or the stock market. Okay, the x-axis is going to be the horizontal axis is going to be the time, and like a calendar, and the y-axis is going to be the value of the stock. As you can see here, it goes higher. So what do you need to do? Go on a new page, take it vertical. I repeat that. Go on a new page, take it vertical. So the title is going to be Cartesian Coordinate System, and you may ask, why do we call the XY axis Cartesian? Because the guy who discovered it was a French guy called Descartes, and that was a long time ago. We're talking about 200 or 300 years ago, and it was a big change. Remember, at that time we wanted to travel all over the world. We wanted to find out our exact location. That was a perfect moment to invent it. Anyway, at the top of the page, we're going to write that little information here, and below the page we're going to stick the PDF that is next to this video in Clickado. Now let's start first with the little theory related to XY axis. It's pretty short. First, what's the point? It helps to locate a point on a plane. Plane, remember, it's not the invention of flying up in the sky. No. A plane is a flat surface in geometry. And we're using two perpendicular axes. Very careful, two perpendicular axes, so they're separated by an angle of 90 degrees. The x-axis is horizontal and the y-axis is vertical. Now, the thing is this, how do we pinpoint a dot, let's say here on the map? We need to use two values, one value from the x and one value from the y-axis. And how do we do this? By using little brackets. X and y, two values, one from the horizontal axis and one from the vertical axis, and thanks to these two values that are between brackets separated by a dot comma, I can locate a dot on a map. Example, imagine I want to know where Mexico is. We can see that I'll need a value first to move my head towards the left side, and in this case, play with longitude, it would be about 100 west. That would be the first value I would write in my bracket. And Mexico, let's say the center of Mexico, I would need a second value from the y-axis, will be in this case 20 north. And that would be the second part of my bracket. So based on Mexico, my coordinate of Mexico would be 100 west, dot comma, 20 north. That's for geography. In geometry, we're going to use just numbers. Okay, that's what you should have written at the top of the page with the title. The second part is this weird little thing, weird little PDF that you have in Clickado. Print it, stick it below the information, and let's look at the information based on a student from last year. That's exactly what I want you to write on all of that graph, and let's understand every part. So you can see that these two y-axes are separated. Let me just make it a little bit smaller, like this. You can see the movement of my mouse. Jesus, what's wrong with me? So you can see that there is an intersection between the y-axis and the x-axis. This is what we call the origin. Good to know. Now, sometimes the x and y-axis only form what we call a quadrant, a square shape here. Sometimes we'll need to make the x-axis a little bit longer towards the left side, forming two quadrants. And sometimes we'll need the y-axis to go down a little bit further, okay, to include some negative value, and we'll form four quadrants. Okay, most of the time we'll just use the xy that forms just one square, one quadrant. Why? Imagine the evolution of your height through time. There will be no negative value. So what's the point of making a giant graph going left and down? So you would only focus on the positive value. So let's focus on the x-axis. If the x-axis goes to the right side, everything will be positive x. No? Any x's that we'll find here on the right side will be all positive. If it's on the left side of the origin, they will be all negative x. No? Imagine the what could be negative temperature. No, temperature could be positive or could be negative. It doesn't need always to be time here. Huh? It could be whatever you want. The y-axis, if it goes up, it's going to be positive. If it goes down, it's going to be negative. No? Another example would be the amount of money you have in the bank. It could be positive or it could be negative. So now, depending on where you are, you're going to write the coordinates in one way or another. If both values are positive, it's going to be x, then y. As you can see, it's always x, then y. Very important that many students make a mistake there. First you write the x, and then you write the y. Imagine I get a dot here. Let me add that on top. You get a white dot here. What would be the value of this dot? It would be 1, 2, 3 x, so 3, and the y would be 1. So the coordinate of this dot would be first 3 and then 1. Not 1 then 3. Be careful with that. It's first the x, the number that is facing this little dot in front of the x, and then the y. So the dot that this shape is facing on the y-axis. Now, if it's on the left side, it means that the y are still positive, but the x, because on the left side, will be negative. And as you can see, when you're in this quadrant, the value is going to be minus x because we're on the left side of the x-axis, and because we're down, the y will also be negative. For the fourth quadrant, x will be positive because we're facing the right side of the x-axis, and because we're down, the y is going to be negative. Okay, so imagine I have this dot here. What should I write as its coordinate? It's going to be first the x, remember, 1, 2, but because I'm going to the left side, it's minus 2, and 1, 2, 3, 4, 5, 6. But because I'm going down, it's going to be minus 6. So minus 2, minus 6. So let's do some exercises, find out if you understood all that. These two exercises are connected to your Click-Edu in ElSoro. The first exercise I want you to do is this one. Is just plot correctly these different dots. So imagine I need to plot this one, minus 4, 10. What should I do? Remember, the first number is x, and the second number is y. Minus 4, 10. Minus 4, and then 10. I will put the dot here. And then do that with all the other dots. Classic mistake is flipping these numbers. So be careful, the first number is always moving left, right, and then after you go up or down. The second exercise is different. You don't locate, you don't try to draw a dot anywhere, but you try to find the coordinates. Sometimes you may need to do something else, and we're going to correct all this together.